Hi friends, this is a special video, one I'm really excited to share with you. Expo modules are one of the most powerful tools in the React Native ecosystem, and today we're going beyond just how to create one. I want this to be a complete resource that shows you what Expo modules are, why you should care, how they work, and who's using them, all in a way that's approachable even if you are new to native development. Then, we'll dive into building a real native module step by step, unlocking advanced native APIs like Apple's on-device foundation models in iOS 26. If you ever wanted to go beyond JavaScript and feel confident bringing any native feature to your application, this video is for you. Let's get into it. Okay, let's start with the basics. The Expo Modules API lets you write Swift and Kotlin code to create native modules and views that integrate seamlessly into your React Native application. It's designed to minimize boilerplate, work consistently across iOS and Android, leverage modern language features, and deliver the performance needed for real-world, high-frequency native calls. All Expo modules are fully compatible with the new architecture, and they work out of the box in existing applications. No need to worry about compatibility. Even better, the API is actively maintained by the Expo SDK core team. These are some of the smartest engineers in the ecosystem, and you can trust this API will be around and improving for years to come. Sometimes you need a native feature that no existing library covers, or maybe you just want full control over how your module works. That's where custom Expo modules come in. Take the Foundation Models API, for example. It requires you to define generables, the structure of the data you want the local LLM to generate. And you have to define this directly in Swift. In this case, writing a custom Expo module makes perfect sense. The good news? Expo modules are built to integrate seamlessly with the Expo workflow. Whether you're using development build, pre-build, or continuous native generation, no extra configuration needed. Just import your module where you need it and you're good to go. But wait, there's more. Even if you are not using Expo in your React Native project, Expo modules are still likely your best option. They work great in plain React Native projects too. And if you want inspiration, just check the Expo repo with over 100 production-ready modules powering apps like Bluesky, Starlink, Coinbase, Notion, Calendar, Brex, and many, many more. By the way, Bluesky is open source and they have great Expo modules. My favorite one is the bottom sheet. Okay, so let's dive into what you're gonna need to follow along with this video. You need to have an Apple developer account to be able to download the developer beta. You need Xcode 26 and iOS 26, preferable a physical device with Apple Intelligence enabled. You need to be familiar with Apple Foundation models, so I would highly recommend to watch the WWDC video that I'm gonna leave in the description. That's all you need. I'm extremely excited to start this video, guys, so I would highly recommend that you follow along with me if you really want to learn how to master Expo modules. Now let's get started. To get started, go ahead and clone the repo that I'm gonna leave in the description. So just come here, copy the link, clone it, and then switch from main to the branch video tutorial starter. This is an app that already works, but doesn't have the module that we're going to create, and it's perfect to get started. Once you clone the project and switch to video tutorial starter branch, let's go ahead and install dependencies using Bun. Now let's go ahead and pre-build the project. So I'm going to say npx expo pre-build and hit enter. This is going to generate the native projects for iOS and Android, and you can see the folders on the left. We are using CNG or continuous native generation, meaning that we don't need to track these projects because we are auto-generating them each time that we run this command. The next thing that I want to do is open this iOS project in Xcode. A shortcut for that is running XED iOS. This is going to open Xcode. Just make sure that you're using the beta version. So if I press Command, this is going to open the settings of Xcode, and you can just double check that you are using the Xcode Beta 26. Then select your project on the left, go to Sign In and Capabilities, and select your Apple developer team. And just to make sure that everything is working, let's select my iPhone. In this case, it's already there, iPhone 15 Pro Max. and let's press play. Okay, and the build is successful. It is installing on my device and it is using the development client. Let me just go ahead and close it. Since I changed the bundle identifier, now I have Foundation Starter and Foundation App as different applications. And it's great because this one is using the development client, which allows us to go and change the JavaScript and enjoy of hot reloading. And the other one is a standalone application, which works without any server running. Perfect. So now this is actually not working because we need to have the local server running. So let me replace Xcode with VS Code. So back to our project. Now let's run npx expo start to start the server. It's using a development build, of course. Now we just need to scan this QR code. So I'm going to open my camera and scan this QR code. Let's allow access to the network so that we can connect to this local host. And if I reload, this should work just fine. Awesome. And we have our application running. Great. With the native tabs and everything, right now it says that it's not available. And this is because I'm just showing hard-coded data right now. But this is like the skeleton and UI of our application. Nothing is going to work, of course, if I go to basic generation and start typing stuff and press generate. Nothing is going to happen. We don't have a native module yet. With this setup, we are more than ready to start developing our native module. So let's go ahead and stop the server for now. Okay, so now that we know that our application is working, we are ready to start implementing our module. To create a module locally in your project, you can run bunx create expo module with the flag local. This is going to be a custom module just for my application, so that's why I'm going to be having it locally. And it's also a good way to start any module. If you decide to open source it later, you can just abstract it from your code base, but this is a good starting point. I'm running bunx since I'm using bun, but if you're just using npm, for example, you can run npx create expo module with the flag local. So let's go ahead and hit enter. This is going to ask the name of your module. In this case, my module is going to be named Expo Foundation Models. Let's type this name and hit enter. And from here, I recommend just selecting the defaults. It's going to ask you the native module name. We need an Android package name. Let's hit enter. And that's it. We have successfully created an Expo module. And on the left, now I have this folder modules. And inside of it, we have the boilerplate of a new Expo module. By default, this module is already compatible with iOS, Android, and web. So if you look at it, we have this web view and web module. This is for web only usage. Let's take a look at the iOS folder. And this is the module. Basically, this is how we can declare a module just by using the Expo module score in Swift. And we can do the same on Android. If you look at the Android module, it's pretty much the same thing, but using Kotlin instead of Swift. But in today's video, we're going to be focusing on Swift. Just by looking at this module, we get a bunch of information like the name of the module, how we can declare constants, how we can declare events that are happening on the native side of my application, and how we can access them on the JavaScript side of the application. And then we have functions, async functions, and even a view. So let's take a look at the hello function. This is Swift code, right? And we're defining this hello function. So if we go to the Expo Foundation Models module TypeScript file, you can see that we are declaring this hello function as well. Meaning that if I now go to my index screen, this is the home screen that we're seeing on the right. And after the examples title, I'm going to have a button that says check availability. And let me start the server. Let me refresh the application. Okay, now I have this check availability, but I'm going to rename this to be check hello function and hit save. So in the on press, we can say Expo Foundation and let's hit enter to auto import. And this is my module. So now I can say dot and I'm going to get access to all the methods that we are defining in this module. And you can see here the hello function. So if I just call this function, this actually returns a string, as you can see here. So we can actually put this in the console. Let's store the value in this variable and then say console log value and hit save. All right. And now, as you notice, something weird happened. And this is because since we created native code, we cannot use live reloading right now. We need to create a new build of our application and pre-build again so that the new build contains the native code that we just created. But just for fun, let's open the console and you can see the error here, cannot find native module Expo Foundation modules, which makes perfect sense. And if I try to just press this button to check availability, nothing is going to happen. So let's go ahead and recreate our application. So I'm going to stop the server, and this is how we iterate each time that we make native changes in our application. Let's close Xcode again. Let's go back in here and say npx expo prebuild. You can specify the platform if you want to just prebuild for iOS. I'm gonna say piOS, and that's it. Now, a pro tip, I would recommend that you always prebuild with the clean flag. This is going to basically remove the previous iOS folder and regenerate it again to prevent any cache. Now from here, we can open again Xcode using exit iOS to open the iOS folder, or you can run it directly on your device. An alternative to run it on your real device is running npx expo run iOS and then specify the device. You can pass the name of the device. So to get the name of your device, you can just connect your iPhone and then go to the locations, select your iPhone, and this is going to tell you the exact name of your iPhone. In my case, Beto's iPhone 15 Pro Max. Let's copy that, paste it in here, and select it as the device that I want to run this build. So let's hit enter. And now the build is in progress. Okay, and the build was successful. Let's see if it launches my iPhone. Okay, there we go. And it's going to load it automatically. So that's a way of building it if you don't want to open Xcode, but actually I would highly recommend to use Xcode, since when we open Xcode, we actually can see syntax highlight when we are writing Swift code. But it's good to know that you can also do that. Okay, so now we have rebuilt our application. That means that now we have access to the native module that we just created just by importing it, right? Just by calling it in here. This is our module. And if I search for it, we are importing these from the foundation models. So let's open the console and now let's check hello function. And each time I press the button, we get the hello world. So what is actually happening under the hood is that we are calling the native implementation of this hello world function. So if you have made it this far, congratulations. At this point, you have integrated a native module into your Expo project. So on the left, inside my modules folder, let's go ahead and remove the Expo Foundation modules view. We don't have any views right now. Everything is going to be a module right now. So let's move this to the trash. And as well, let's remove the web implementations. Since we're not going to be using this module on the web, let's just go ahead and remove it to keep things simple for now. Let's go to the Expo modules config JSON and let's remove web. Let's just keep Apple and Android. Let's remove this Expo Foundation models view TSX. We are not going to be compiling this on Android, but if you want, we can also remove the Expo Foundation models view Kotlin file. Now let's go to the types. And on the types, I want to actually remove everything that we have in here, and let's remove the imports. Let's hit save. Let's go to the module. Let's remove these functions that we are declaring here. Okay, so this is how it looks. We are still importing our types and exporting the class. But nothing is in there. Let's go to the index and let's remove this view. Let's just keep things super simple like this. Okay, once that's done, let's close everything. Now, if I go back to my index and import all as Expo modules module like this, if I come down here, now we're going to get a warning that says that the hello world function is not implemented because we just deleted it. So let's go ahead and remove it. Okay, so now we are ready to start developing in Xcode. Let's stop the server. Let's clear the terminal and open the iOS folder in Xcode again. All right, just let's make sure that everything is looking good. I'm going to select my foundation starter on the left. And if I go to signing in capabilities, everything looks good. Now, to access the source code from our native module, we can select the pods on the left. The development pods folder contains the source code of all the native modules used in our application. So as you can see, we already have a bunch of Expo modules, but if you take a closer look, we have the Expo Foundation Modules folder, which is our module, our custom module that we just created. And as you notice, this is red because we just deleted the view, but that's fine. Let's just double click on the foundation modules. And this is our native module. And like I said before, now at this time, I get syntax highlight because I'm using Xcode, and now I can enjoy of type safety. Now this is actually complaining because I deleted the view file, which makes total sense. So what I want to do here is just go ahead and delete everything to start fresh. We can leave the name. Let's delete the events, functions, and everything else. Okay, now on the left, I'm going to right click in here and delete this file to remove the reference. All right, and now we're ready to actually start working on our module. If you have any questions about anything that I'm gonna be doing right now, I would highly recommend to come to the Expo documentation. Under Expo Modules API, we have the reference, and you can check the module API reference. And if you want to learn more about each specific thing that we're doing, for example, the name, it says the name of the module and things like that. You can come here and learn everything. But one thing that I want to focus right now, and actually we're going to start doing, is define records. Records are basically the way you type your module. When I'm creating a native module, I like to think that I'm basically doing kind of like an API for a backend, and I need to declare the structure that I'm going to be sending to the client side. And you can think of it like the native side being the backend, and then the JavaScript side being the front end. So we need to declare the data that we're going to be sending to the client, right? From native to JavaScript. And the Expo Modules API allows you to construct these complex data structures to have a fully typed native structure by using this record property. So we can actually copy this example if you want to. So to keep things simple, on the left, let's select the Expo Foundation Models, and I'm going to press Command N. This is going to create a new file. Let's just select a regular Swift file and press Next. The name of my file is going to be records. This file, of course, is going to contain all the types or records that we're going to be sending to the JavaScript side. Under targets, make sure that Expo Foundation Models is selected. That's all we need actually. So let's go ahead and create. And now we have this records file, and we can actually drag it to have it in here. And this is my file where I'm going to be declaring the types. So we can paste the thing that we copied before. Now, since we're going to be using record, we need to import Expo Modules Core. Sounds good. Now, instead of having this name, I'm going to rename this to be Foundation Models Availability. So let's start with a Boolean is available. And it's a good idea, guys, to always initialize these variables. So by default, this is going to be false. This is actually good enough at this point. If you want, you can just keep a Boolean to validate if it is available or not, but we can go further than that. We could even have a field with the reason why this is not available. And this could be an optional string. And I'm going to initialize this to be nil. Let's define more fields. We can have a variable like device supported, which is a Boolean. We can initialize this to be false, and we can even do more complex things. Let's declare a variable that is going to return the operating system version. So let's call this OS version. This is not optional, and I want to initialize this to the version of the iPhone. So we can actually access that super easily by using the processinfo.processinfo.operating system version string. This is a string containing the version of the operating system on which the process is executing. So just like that, we're able to access the native stuff, right? And we can actually put that as an initial value on a record, which is amazing. You can add more fields if you want, but right now this is good for me. Now I can actually use this Foundation Models Availability to type my function for permissions, or to see if we actually have the foundation models available. Since Apple Foundation Models is going to be available on the latest devices, many iPhones and all devices won't have access to this feature, right? So we need to make sure that we can validate that the LLM is available before we can actually use it. And this is the purpose of this function. So let's declare an async function, and the name for this function is going to be check availability. In Swift, we can declare the return type of a function just by calling the record that we created here, which is foundation models availability. And this is like this, okay, foundation. Okay, so this ensures that now we have type safety on the native side. And now, of course, Xcode is complaining because we are not returning the foundation models availability. So I can say return. So if I say return foundation models availability like this is going to return the record with the initial values. False, false, false. But we actually want to run logic in here, right? So to keep things clean, instead of just doing my logic inside this async function, we can actually create a new file, or we can do it down here. So let's create like a section. In Swift or Xcode, you can mark sections like this. So I'm going to say foundation models availability check, and then let's create a function. So I'm going to say private. In Swift, to declare a function, you just say func, and I'm going to call this get foundation models availability. And I have nice autocomplete, which is cool. So we are fully typing the return value of this function is the record that we defined before, but actually this function is going to be an async function. So we can just add here async. And this is where things get interesting. At this point, we're actually going to start using the foundation models from Apple. And if you want to learn more about how you can actually start using this, you can check out their documentation. This is in beta right now, as you can see here, and you can see the usage of this module. But what we need to do here is come at the top of our file and import foundation and foundation models when we're going to be using them. Okay, now at this point, what I want to do is start initializing the data or the record that we're going to return. So we can save this into an availability variable. We are initializing a new record, and then we can overwrite the default values that we define in here based on the actual availability on the current device. So we need to check if available. This is going to be available only on iOS 26 and macOS 26 as well. This is how you can validate the availability on Xcode. So let's grab the system model by using the system language model dot default. Then let's grab the variable is available, and we can now use this system model that we initialize. So I can say is available. We also have this availability, supported languages. So now the thing I care is this Boolean, if it is available or not. And if you press Option, click, you can double check that the value of this is Boolean. And once we are sure that this is a Boolean, we can grab our record in here. We can say availability dot is available equal to this variable in here that it's actually going to contain yes or not, depending on the device. Then we can say availability dot device supported equal to true. So at this point, I'm initializing it to true, but actually if is not available, we can overwrite the availability reason equal to the device does not support foundation models. This is totally optional, of course. If you want, you can just return the Boolean value. But yeah, otherwise I can say availability reason, and actually this else, it's going to be for this if statement. So I can put it in here. So if the user does not have iOS 26, the error is going to be foundation models requires iOS 26. Otherwise, maybe the user is actually using iOS 26, but they don't have Apple Intelligence enabled, for example. So in that case, the error is going to be the device does not support foundation models. You can change the message if you want to. And then finally, we can return our availability. And let me just close this. And this is our function, super simple. Now we can come here, and instead of returning this structure, I can say return await. Remember that this is an async function. Let's call it get foundation models availability. As clean as that, guys. Now I can actually save this, and we need to rebuild the application. So I'm just going to press play to rebuild it on my iPhone 15 Pro. While this is building, I'm going to switch to VS Code. I'm going to start my server. And let's minimize the console. And now let's go to the module. In my types inside source, in here, I'm actually going to delete this type and declare a new interface that is actually going to match exactly the record that we just defined it on on our module. This provides fully type safety on the JavaScript side or TypeScript side. Let's go to the foundation model. We don't have events anymore. Let's delete that. Let's delete this in here as well. Now this looks cleaner. And inside this class, we can start defining the actual functions that we just created. So if I go to my Swift foundation models again, I can just copy the name of my function, which is check availability, come back in here and declare it. It is going to return a promise with the foundation models availability. All right, let's hit save. Now we're type saved on the TypeScript side as well. And we're actually ready to start using this because the build is ready. So let's go to the settings screen. If I go to the settings screen on my phone, right now you can see that available says no, and we can start using our stuff. So instead of having this any, I can use the type that we just declared, foundation models availability, for my state variable, and we can import this from our module like this. This is coming from the types. And now we can call the function when the component mounts using a use effect like this. So let's import use effect from React. And then let's import as well our foundation model like this. So once we import the foundation model, we are going to have actually fully type safety with my function get availability. And if I hover, I can see that this is a promise that is going to return the foundation models availability data structure. So once we get that, we can set the availability to the state. And then we are just using the availability to populate our UI. So let's hit save. And suddenly on the right, I get real data. Device is supported. OS is version 26, and it is available. So how cool is that? And it was super easy, honestly. And it's super enjoyable to me being able to declare my records, being able to have fully type safety across native and TypeScript. Is just an enjoyable experience building a native module like this. And this is actually going to be super fast. So if I refresh the application, as soon as I go to the settings screen, notice that it says yes by default. So this runs instantly. Okay, now at this point, we can actually start using the local LLMs. So let's start with the basic generation. And from here, we can repeat the process, guys. So let's go back to the records. Let's define the data that we are going to return for our next functionality, which is the basic generation of text. This is simple. We are not streaming data yet. So for this, I'm going to declare a couple of records. First of all, when we handle a basic generation, we're going to get a prompt from the user, right? So I'm defining the record for the prompt. It's generation text request. It's going to get a prompt of type string, and by default, it's going to be an empty string. Then once we use the local LLM, we're going to return a response. So in this case, I decided that for the response of the LLM, I'm going to have the token count and the generation time, just so that we have, some data to show. This is the metadata. And apart from that, I'm going to have the generation text response, which is what returns my function. It's going to return the content that the LLM returned, which is a string. At the beginning, is going to be an empty string. And then the metadata, which is going to be of type generation text metadata, which is this record that we define it in here. And you can see now that we can define very complex data structures using the records from Expo modules. So I'm defining the data. And finally, I'm adding this optional error, initializing it to be nil. Pretty solid stuff. So let's go back to here, and I'm going to minimize this get foundation models availability, and let's go ahead and create a new function. Same stuff, guys. We can declare a new async function. In this case, I'm going to call it generate text. It's going to get a request. In this case, as you noticed, now the parentheses are not empty. And now I'm defining that this function gets a request of type generation text request, and then returns a generation text response. Now, finally, I'm calling the generate text function, passing the request. So of course, this is complaining because we need to create our function. So we can do the same thing. Private function get text. This is going to get the request and is going to return the response. So we can actually do pretty much the same thing. Let's initialize a new response record by saying let response equal to generation text response. This is going to contain the values. Now, based on what the module responds, we're going to overwrite the defaults and then return that, right? So that to stop the complaints here, let's just go ahead and return the response like this, and this should get rid of it. All right, so same thing. We need to check that the foundation models are actually available and we're using iOS 26. Otherwise, we can return the same error. So in this case, if the user is not using iOS 26, I'm going to set my error to be foundation models requires iOS 26. Okay, and then we return the text response. So let me actually rename this to be text response. And let's rename this as well. And actually I can just remove this and put it inside of here. And this should work. Now inside this, I'm going to create the equivalent to a try catch. And we can do that in Swift using a do catch. So I'm gonna say do catch like this. And then let's put the return inside the do. All right, and let's start defining our variables. So start time is gonna be equal to a date. So I'm going to count the time that it takes for the LLM to respond. So we need to keep track of when it started. Let's get the prompt initialized. This is going to take the prompt. So we can grab this from the request.prompt. And if you take a look at this prompt, just so that everyone is on the same page, this is just a structure that represents a prompt for the local LLMs. And then we need to create a new session to use the local LLM. So let's create this session equal to language model session. This is an object that represents a session that interacts with the language model. Once we initialize the session, we can pass the prompt by saying let response equal to try await. Let's use the session. And the session comes with a lot of stuff like streaming responses or just a simple response to, and then we can pass a prompt, which is this variable that we define in here. And that's pretty much it, right? So this is actually going to throw an error in case there is something wrong. And we are going to catch it in here and set the error based on what happened and then return the response. That's pretty much it. Now, once we get the response, we need to store it in our text response. But after that, I want to keep track of the end time. And then let's declare a variable to store the generation time, which is going to be end time dot time interval since, and this gets a date, which is the start time. Then let's try to calculate the number of tokens. So I'm going to have this variable, let token count, which is going to be equal to the response content count. So if you say response dot, you get the transcript entries or content. And then the content is going to have count, hash value, and stuff like that. So I'm just grabbing the count and divide it by 4. This is to get a rough estimate. And then finally, we can say text response dot content equal to response.content, text response.metadata. We need to initialize the generation response metadata. This is going to get the token count, which is the estimated count, and the generation time, which is the generation time. And if you are wondering where is this coming from, this is actually a record that we define in here, and we are just initializing it in line instead of doing this thing and then override each property. You can also call it like this and then pass each variable. So we are setting that into the metadata of the response, and finally we can return the response. And that's it. Another beautiful and clean function in our module that we can simply call in the async function here, generate text. Now we have added native code, which means that we need to rebuild our application. So let's press play and let's go back to VS Code. Let's repeat the process, guys. First of all, I want to go to my types. Basically, it's the same thing. We need to generate the types. In this case, I'm going to create an interface for the request. It gets the prompt and then an interface for the response, which contains the content, metadata, and all the stuff that we are returning from the native side. So let's go ahead and hit save. Let's go back to our module. And now we should have access to the generate text function, which takes in the request. Let's import this from the types and returns the generation response. Cool. So let's hit save. And now we are good to start using it. So if we go to the screen, basic generation, in here, we can start typing the response, for example. Right now, nothing is working. So let's go ahead and type the response to be the generation response. Let's import this from the generation response, Expo foundation models. From here, it's just a simple matter of typing the prompt. We have a variable when it's loading, and that's pretty much it. Now, I have this function that I call each time that we press the generate button here. So if I go to the basic generation, I have this generate, right? And if I type test, it is enabled. So when I press this generate button, I'm calling this function. So the first thing that I want to do is just a try catch. I'm setting my variables to be loading, error equal to null, set response equal to null, and then we can call our Expo foundation models module. Let's import this. And now I have access to the generate text function, which takes the prompt as a parameter. So let's pass this variable from the state and just trimming it. And this is going to return the response. So we check if we have an error, we are setting the error. Otherwise, we set the response. And that's pretty much it. Now in the UI, just having a text input. When we change this, we set the prompt. And when we press the button, we call the function. That's pretty much it. When it's loading, I show the generating. And finally, the response. And finally, if I keep scrolling down, you can see that we have an error. We show an error. Otherwise, if we have the response and it's not loading, I'm going to be showing the response with the content. Again, guys, this is fully typed. So I can say response.content, metadata. I actually know that the content is always going to be there. The error is optional, so you can validate accordingly. But yeah, so let's hit save. And now let's test if this works. I'm going to call generate. And you have the response from the model. It took 12 tokens, 1.3 seconds. And then I can start asking more complex questions like fun fact about Mars. Let's start generating. And it generates like a good amount of text. And it's still pretty fast. At this point, I don't think we really need streaming, but things actually get kind of, I wouldn't say slow, but for example, if you ask for tell me a story and then generate, each time that I ask tell me a story, it actually takes time to generate. And we don't have any feedback. It looks like something went wrong. But after a moment, once this is done, we're going to get the chunk of data, as you can see there. So this is how it looks. A bunch of data. So in this case, it would be nice to have streaming so that we know when this is happening. If we go to the release build that I created under streaming chat, if I say tell me a story, you notice that this is actually super fast to react. And it takes time because it's generating a bunch of stuff, but we can actually have an instant response and start reading it. Okay, let's cancel this. And then I almost forgot about structured data. So let's actually do structured data and then streaming. Okay, so let's do structured data quickly. Let's go back to Xcode. Let's do the same thing, guys. Let's declare some records for the response that I'm going to be handling here. JavaScript side, we're going to pass the prompt. And then we're going to have metadata, which is basically the same thing that we had before, which is the token count, the generation time, and the model. This is actually totally not related, so we can actually just remove it. And then the response is going to have the data that I want to define. So let's define a record for the user profile that I want to generate. And this is how it looks. Metadata, it's the one that I define in here, the structured generation metadata, and then an optional error in case something goes wrong. So as you notice, we can start creating more complex records, like in this case, the profile record. It's going to have name, age, interest, location, and then we need to create the location record. So let's create the location record here. For the location, it's just city and country, and that's it. So these are my records, the data that I want to return. We can hit save. If we go to the documentation of Apple, you can learn more about the generables, and basically are structures that you defined natively with the kind of data that you expect from the local LLM. So you can pass this macro guide with description about the field. So in this case, you can have search terms, which is going to be a list of suggested search terms. And then you can also define like the count of how many you want, passing the type, in this case, search term. And you can find more complex stuff like search term is going to have an ID, and then it's going to have a search term, and then define another description for the search term. In this case, we can say to the LLM, this search term needs to be 2 or 3 words, search term like beautiful sunsets. You can provide examples to have better results. So let's use these generables in our application. Let's go back to the project. I'm going to select my Expo Foundation Models folder and just press Command N to create a new Swift file. And I'm going to call this file Generable Data Structures. Notice that the target is Expo Foundation Models. Let's press Create. And let's move this up in here. And let's define the generables. Let's import foundation models, and then we can define the structure like this. So if it is available on iOS 26, we just call the generable. This is coming from the foundation models. So as you notice, if I comment this line, it's going to start complaining. And from here, I can just start defining the properties of this structure, like the user profile, name, and the description about this field, like the user full name. And you can, specify first and last name, for example, right? Then the age, the user age in years. And as you notice, each field you can provide a guide. And the guide is actually optional. And you can also combine more structs. So let's create a location with guides, like the city name, and we can say from the US only, for example, right? And let's close this in here. We also need to pass the available here because this is only available on iOS 26. And this is how you can declare the generable data structure for your specific needs in your application. And once we have this, we can just pass this structure to the LLM. So let's go back to the module. Now let's minimize the generate text function. Let's create another private function in here. In this case, we're using our types, structure generation request and structure generation response. So let's initialize a variable for the response like this. We can return the response so that it stops complaining. And then basically we can do the same thing that we did above. So we can actually copy paste it. It's going to be a do catch. In case we have an error, we update the response with the error accordingly. In this case, something went wrong with the generation, right? If something goes wrong inside this if statement. Otherwise, the error is that the user is not using iOS 26. So inside the do, let's prepare to prompt the LLM by creating a session and initializing the prompt. So here's the session using the language model. We are initializing the prompt from the request.prompt, and then we can grab the response from the LLM by calling session respond to, and then we can pass a second parameter generating, and this is going to be the data structure that we want the model to generate. In this case, I want the model to generate a user profile. So we pass this data structure in here. After we get the response, it's just a matter of setting the values of the response. So I'm going to paste this in here. So if I question mark this, this is going to return a user profile, as you can see there. So I'm initializing this profile based on the content. And then we initialize a new record using the user profile record. And then we just map the properties. So the record name is going to be equal to the profile name, record age. So basically we are just passing the response to the type that we created before. Same with the location, same with the end date. It's the same thing that we did above. And for the token count, we can estimate the token count by calling this function. And this is another example of how you can start abstracting utility functions into another files. But in this case, I'm going to create this helper function that ChatGPT created for me. It's just going to estimate the token count based on the record. We pass the record in here, and that's it. So we initialize the metadata as well, and finally, we return the response. So if I hit save, we're actually good to start implementing this. This is not super complicated. I guess this looks like a lot because we are mapping a bunch of data, but this is custom data for our specific needs and business logic of the application, which makes total sense. It could be simpler for your case or maybe more complex, but you can abstract it in helper functions. And at the end of the day, it's going to look not that bad, right? So let's minimize this generate structured data. And now we need to declare our async function in here. So basically the same thing. The name is going to be generate structured data. We get the request, we return the response, and we just call return await the generate structured data function passing the request. As simple as that. Now we are good to start using this in JavaScript land. So let's rebuild the app and switch to VS Code. Let's go to the types. Okay, the build is ready and should be working fine. Let's go. All right, and from here we can keep going, right? So I'm going to just define the request and response. This is the exact data that my model is going to respond. Okay, so I'm just grabbing these from my records from the native side. This is how my type looks like. And then we can go to the module and just call our new function. Let's import the types. It's going to return a promise of type generation request. And now we're good to start using it. So let's go to the structured data and then we can start typing the response, right? So this is going to be structured data. This is coming from our module. Then we can start using it in this function. When we call the generate structured data, I'm just calling my module with the generate structured data function that now it's fully available, passing the prompt. And then based on the response, we can set the error or set the result. And at the end of the day, I'm just displaying the result on screen. So let's try this out. Let's go to the starter. Let's go to the structured data and generate a 25-year-old. Okay, guys, so a little bit of bad news because I'm trying to test this generation structured data. I'm actually getting an error regarding the LLM. Pretty frequently, this one right here. And I think this has to do with being a beta version at this point, because I'm testing right now on the streaming, on the production one, and I'm getting the same error. And yesterday it was working, so I'm suspicious about Apple intelligence. And since this is a beta version, well, I'm not sure what's wrong. But let's keep moving on to the streaming chat. Hopefully this works for you. So the goal for this section is to basically have this functionality, streaming chat, just a simple response. And for this, we're actually going to start using some more advanced features of Expo modules, like defining events and emitting events each time that we get a chunk of data from the local LLM. So let's start by doing the same thing. Let's start by defining the data that we're going to be sending to the JavaScript side. So in my records, I'm going to paste some streaming records that I came up with, which is the request. We're going to pass a prompt and session ID. And then for the session, we're going to have an ID for each session. And this is because when we start streaming, we need to keep track of if we are actually streaming data or if something went wrong or if it's done streaming. So for that, I'm going to have this streaming session. It's going to have a unique ID. And then the streaming chunk events. So each time that the local LLM is generating a chunk of data, we're going to send an event to the JavaScript side and use that. It's going to contain, of course, the data, and then we can update the UI based on that. It's going to have the session ID, the content is complete flag, the token count as well. And some of these fields are totally optional, like I said before. Then we have streaming error event, the session ID and the error. Streaming canceled event, we want to provide the ability to cancel the streaming. So to do that, we need to pass the session ID, and this is why we're also tracking the session, because we can cancel it from JavaScript. So we send this event, and then we check if we're actually streaming on the native side, we can cancel the session. And finally, we have the streaming chunk event. So what we are sending on each chunk, we are sending data, the session ID, and the schema type is complete, is partial. Okay, so this is how it looks. This is basically initializing an empty JSON string, you can think of it. So once we have this, let's press save and let's go to the module. Okay, so after this function, I'm going to define a couple of functions for the streaming implementation. Now, since we want the ability to cancel each streaming session, I'm actually going to declare two private variables at the top of my module. One is going to be to keep track of all the sessions that are active. So usually it's going to be just one. So we're going to have that in an array of strings. And then we're going to store the active streaming task for cancellation. This is so that when we get a request to cancel a specific streaming session, we can check the streaming task, and then if we have a session that is matching, we can cancel it. Okay, so once we have these variables, I can come down here. Okay, and in this case, it is complaining because it's out of the scope, and I just realized that all these functions are outside of my module class. So let's put them inside. I'm going to just remove this closing curly brace and then put them in here. That way we should have access to these variables. Okay, so now we have this start streaming session function that is going to get the streaming request and the streaming session. It's going to return the streaming session. So when we can press a button on the JavaScript side and start the streaming. So for that, we're going to need to start a session record. We define this in our records, and then we are going to initialize a new language model session by getting a unique ID. So we can set the session ID for this specific session, and then we create the language session. After that, we store the session in our record to keep track of it in case we need to cancel it later. And then we can create a task for the streaming of the data. So we initialize the prompt based on the request prompt, and then we call, in this case, string response from the session. And this is a method that we can use from the foundation models to string response. So we can respond to this specific prompt that we're initializing here, and then we're iterating over the current content of the stream. In the loop, we can check if the task is canceled. Then we throw a cancellation error. Otherwise, we continue. So the stream returns the full accumulated content each time, meaning that it's not going to return just each chunk that we can append, but it's going to return everything. But each time is going to be different. So we'll send the full content to JavaScript to handle it. So we can just calculate the current tokens. This is an estimate as well. And then we send the full content as a chunk event. So we initialize a new streaming chunk event. We map each variable. So the important part here is the content, which we are grabbing it from the loop in here. We're iterating for each current content in the stream, and we are sending that as content. Okay. Now, something very important here is that we are going to send an event once we get this chunk. And the event that we're going to be sending, and this is actually a method from Expo modules that allows us to send this data each time on each stream super fast to the JavaScript side. And the data that I'm sending is just the chunk event, but transforming this to a dictionary. And by the way, I almost forgot that after declaring my functions in here inside my definition of the module, we can also define the events that we're going to be sending to the JavaScript side. So the event is on streaming chunk, on streaming error, on streaming cancel, unstructured streaming chunk. And this is a different event for when we are streaming a structured data. I don't think we're going to have time to cover that, but we can go over that in a moment. But anyways, once we get the chunk, we are sending it with the event on streaming chunk. So each time we are sending chunks, sending events. And once the streaming is completed, we grab the streaming chunk event, initialize it again, and then just set it to be an empty content. At this time, the JavaScript side should have everything. We set this to be complete and basically reset everything and send a final event on streaming chunk, passing the completion event to dictionary as well. And then just clean up. Once everything is done, just remove the streaming session from our map of sessions, and the streaming task as well. We are going to remove the ID. In case we have an error, we're just going to remove it as well from the sessions. And down here, in case of an error when we're sending data, we are as well removing the sessions and also sending an event on streaming error. And the data for this is going to be the error event to dictionary as well. And this is because we need to change this. We need to send this as a dictionary because sending events only accepts a dictionary of strings, as you can see there. So that's it. Then after this, we store the task for cancellation. This is while we are streaming. And finally, we return the session. Okay. This is to start streaming. This is a function to start streaming and handles cancellation, of course. So it adds the session to the records that we have and starts the streaming. And then we have another function to cancel the streaming session. This is going to take the session ID that we want to cancel, and then we check if it is in the streaming task record, and if it is, we cancel it, okay? And remove it from the map. And finally, we remove the session, so we can call the streaming session dot remove, and finally we send an event on streaming cancel with the data cancel event. So now we have two functions to start streaming and cancel streaming. We are storing the sessions that we are handling. So now we can define these functions inside our module definition. We set the start streaming function that gets the streaming request and returns the streaming session. And then we expose as well this cancel streaming session, which gets the streaming ID and returns void because it only cancels the session. Okay. And this should actually work for a simple response. We are not passing any generables yet. We are just responding with the string response to this prompt that the user is going to send on the request. So let's rebuild this and let's go back to VS Code. We can just define the same records on our types, the streaming request, the streaming chunk. Basically, it's the same thing, but with TypeScript interfaces. So let's hit save. Let's now back to the module, and then back in our module, now we should be able to handle streaming events. We can fully type this by importing our types and our streaming session. So now we should be able to have the start streaming session and cancel streaming session. But if you remember, we also define events. So let's go ahead and define the events here in our module. And let's type this by importing from our types. So what we're doing here is just adding a listener for the event type, and we're defining the events that we declare in our module on start streaming, on streaming error, and on streaming cancel. That way we can use these events to listen for changes and update the UI accordingly. So let's go ahead and hit save. And the perfect way to use this is creating a hook. So let's go ahead and create a hook that is going to abstract setting up the listeners and things like that. So I'll create this use foundation models hook. And in here, we can handle the state and updates depending on the events and functions. So let's walk through it quickly. I'm importing everything from my Expo foundation models, stream cancel type, the chunk, the error, and the session. And then I'm just defining the state that we're going to be handling depending on the streaming. So the content, the session, I'm typing this, by the way. If we are loading, if we have an error, the token count is just state variables. And then I'm defining two references, one to the subscription ref and one to the ID ref. And then we can set up the listeners in a use effect. So we set the event listeners for the on-stream chunk. And the way we do that is just by calling the add listener. And this is going to take the event listener that we want to type, on-stream chunk in this case. And this is fully typed, by the way. So we can define it. And then we know that this is going to get an event of type streaming chunk. Here's the type. And then each time that we get a streaming chunk, we can grab the data from the event. So in this case, I'm grabbing the session ID and we are validating if it's different from the current, then just return. Only process events for our session, of course. And then the event, if the event is completed, we set the state accordingly. And then if it's not completed, we are going to keep setting the content of the stream. Okay, so this is basically the only one that we should need to have the functionality. But of course, we want to handle if we have an error accordingly. So we can add a listener in case we have an error for the current session. We set the error. If the user cancels, we are going to listen for that event as well. That is going to come from the native side. And then we set the state accordingly. Down here, we are setting the reference to be 3 reference, 1 for the chunk, 1 for the error, and 1 for the cancel. And finally, when we unmount this component, we are just clearing all the subscriptions by calling the cancel streaming session, passing this session ID reference. Okay. And then we have a function to start the streaming using a callback. If we already had a session, we're going to clear it before we start a new one. This is what this is doing. And then we start, the basic stuff, which is start loading, start the error to null. The content is going to be empty at the beginning. And the session is going to be returned for the by the start streaming session. And this takes the prompt of the user. So once we have the session, we can validate if we have an error. Otherwise, we're going to set the session and the reference for the session ID. And that's all it is to it. If we have an error, we catch it and put it in the state. We have a function to cancel the streaming. We're checking the reference. If we actually have a reference, we're going to call the cancel streaming session, passing the session ID, and reset the reference to be null. And that's basically it. Then we're exposing as well a reset function, and this is totally optional. This is going to reset the state. And finally, we're returning all these functions with this hook, which should allow us to now go to the streaming chat and just import our hook. And let's bring this from our module like this. And now we can actually use this data. So let me just go ahead and replace this current state that I had before. And in here, we can call these functions that I had commented before to cancel and start streaming. So if I hit save, let's open the console just to make sure that everything is working fine. And this should work now. Let's go to the streaming chat and let's say hello and stream. Awesome. And as you notice, a lot of things are happening, but Expo modules actually handles everything super fast. And that's why we are getting, these updates super quickly. And now if we try to do the same thing, like tell me a story, this is going to generate a bunch of data. And if you remember at the beginning, we did it and we didn't get any response after 8 seconds, I think. And right now this is instantly streaming data, which is really cool, is that this is actually going to work offline as well. So great for local first applications. And here we have the summary, the tokens, and everything. Now let's stream this again and cancel it. And as you notice, when we cancel, we stop the streaming, we clear everything. And if I dismiss, this is going to clear everything as well. So super cool that we're able to stream. And at the end of the day, we end up with this beautiful, this beautiful custom hook that is really easy to use. And what I really want to highlight is that when you're creating an Expo module, the code is actually extremely well structured, well maintained, and just high quality. That's something that I really like about Expo modules. Allows me to write a type-saved custom module on the native and on the JavaScript side. Well, this video now is getting super long, guys. But if you made it this far and if you want to learn more about streaming structured data and how this would look like in the code, let me actually show you. I'm just going to walk you through the current implementation that we already have. So let's see how this looks for streaming structured data. First of all, same thing. We're going to define the records that we want to use, and you can find this in the source code down here. But for streaming structured data, we just need to keep track of the session ID that we are streaming in case we want to cancel it. And we're getting the prompt as well. And then we have this record for streaming session for structured data. In this case, it's just session ID is active, total tokens, schema type, and error, and that's it. Now, in this case, we need to define a generable. So if we take a look at the generable data structures, we have a product, which is what we are seeing on the demo here. This is a product and I can change the name. For example, this is like a sound wave, but I ask for headphones, but I can change this to be an iPhone, for example, right? And look at that. Now I have an error. Let's see, premium phone generate. Okay, so sometimes that happens, and this is because it is a beta, and you shouldn't rely completely on this model. Like I said before, not many devices are going to have it, but these modules are great for summaries, for categorization, and you can learn more about usage in the WWDC video that I recommended to watch at the beginning. But yeah, so we are defining this product and we are providing a description. So for example, as you notice, I'm always asking for the price to be in USD, and you can play around with this to get us a better sense of what kind of responses you're gonna get from this model. Let's keep in mind as well that this is a local LLM and it's not super powerful. You cannot compare it with the latest modules from Anthropic or OpenAI. But yeah, so once we define the generable and we provide the structure, we can go back to the module and let's take a look at the start structured streaming. This function is going to get the structured streaming request and it's going to return the streaming session. So we start again the same session. We set the schema type to be product. And this is because I was handling multiple data structures previously, but now I decided to simplify to only have a product, but you can generate any custom data depending on the schema type. But yeah, in this case, a product, we generate a new session, initialize the session with the model, store the session, and then start the streaming response. So in this case, we pass the generating, we pass the product. This is what we're generating, and this is totally optional, but you can pass options, by the way. So generation options, you can pass the sampling greedy, and we have more things that we can pass in here. So for example, if we take a look at the generation, we can pass the sampling, and then we can pass the temperature and the maximum response tokens. So if you want to specify maximum response tokens, let's say 10, you can do that here. So once we have that, include schema and prompt equal to false. This is another variable that you can set. And then we pass the prompt like this. And this is good because it allows us to give more context to the LLM. So in this case, I'm giving it the context of give it a real name, price, category, because at this point, the model knows that it needs to generate a product. So I'm just saying, just give it a real name, price, category, description, features. On top of that, we're passing the prompt of the user, which is going to influence the result of the final data structure. And then after that, we're just streaming the chunk. And we're doing basically the same thing that we did previously when we were handling the structured data, but on each chunk. So this is going to return a partial product each time. And then for each partial product, we are generating a new product data and sending that on an event each time that we generate a new chunk. So based on that, we send that event. Once it is completed, we reset everything and we clean up the session. If the task was canceled, we removed everything as well. And if we have an error, we removed everything as well. So it might be actually a good idea to abstract these functions. But yeah, this is at the end of the day easier to understand. In this case, we are sending an event on streaming error. We pass the error event, and that's pretty much it. So this is returning the session. And for the screen, I'm actually reutilizing some of the some of the functions that we had before. So if we take a look at the streaming structured data, I created this hook to keep things simple in here. But if we take a look at the implementation, we're adding a listener for the unstructured streaming chunk, and we're reutilizing the onStream error and reutilizing the onStream cancel from the simple streaming screen, and pretty much the same thing, right? We are just setting the state. And yeah, so once you have the previous implementation, implementing the streaming of structured data should be fairly easy. So let's try to to end this video, let's try to generate a different product. So let's say wooden table, for example, and generate. Okay, and as you can see, it says oak table, which is really nice, and a nice description, price. It is very expensive, but yeah, in stock. Cool. So yeah, it is influencing the end result. And that's it for this video, guys. It was longer than I expected, but of course I went ahead and kept adding more and more features, because once you get the hang of writing an Expo modules, it's very addictive to keep adding more and more features, because you actually have the power of the full native capabilities. So anything that your device can do, you can expose that through an Expo module, which is exciting, even if it's a beta version like we saw right now. So I hope you liked this video. I hope you enjoyed it as much as I did recording it. Please let me know in the comments if you have any questions, if you would like me to create another video like this, maybe creating now a native view, for example, or if you just have any questions, feedback, comments, if you tried it or not. Don't forget to check out the source code down here. Don't forget to give it a like and subscribe. Thanks for watching, and I'll see you in the next one.